Cleaning the eyes, especially for the refractive surgery like LASIK, PRK, ICL, and especially for identifying those form first keratoconus cases. Now, each technology which has been adapted in these devices has merits and demerits, so we should be knowing about it, how to go about it, and definitely whatever parameters you get it from them, you can actually use it for planning a particular surgery. So I'll be dealing with the working principle basically of the Schimflug imaging, because Schimflug imaging or photography is what is used in the latest devices, and it works on the basis of something called as elevation maps or called as elevation mapping. Now topography, actually it is derived, everybody knows it's a Greek word, topos and graphein, so it actually gives a graphic representation of the geometrical properties of the corneal surface. Now Placido based and elevation based, these are two different devices available in the current refractive surgical services. Of this, Placido has been there for a very long time, and in that TMS and Keratron Scout have been the most commonly sought out and commonly used. But now Pentacam, Cirrus, Galilee, Opscan, they are like the upcoming, and we should be going into much detail about how it is helpful for us in the refractive surgical practice. So Placido based, as we know, the Placido rings are placed with the image which is reflected is captured by the computer with the camera, and then it is analyzed, it is given in a digital form, and it is put in a color coded map with the help of the Louisiana State University color coded map. As we know, the flat curvatures, flat areas are given in cool colors, the normal areas are given as green and yellow, and the steep areas are given as warm or hot colors. So this is how a normal spherical round cornea, green color because this is what is normal. But when we look at these different maps, we have something with the rule astigmatism in the first picture. Definitely the steep axis is given in hot color and the corresponding opposite flat is given in cool colors. Similar for the against the rule and again for the oblique astigmatism. Now the irregular astigmatism, those were regular. Now irregular astigmatism is a totally asymmetric presentation. We find an inferior, some part of the cornea showing so much of hot color. In the other picture you can see we have multiple in a different area. So the first one definitely represents something called as keratoconic or a keratoconus cornea, and the other looks like a PMD, pellucid marginal with a cracked claw appearance. Now apart from that, any anterior corneal scarring, especially in the posterior, the post penetrating keratoplastic cases, we have a lot of irregular astigmatism, which is helpful with the topography definitely. But what are the limitations? We cannot get any data from the peripheral cornea as well as from the posterior corneal surface with the regular corneal topography machines which have existed. So therefore there is no complete pachymetric evaluation possible. Now the anterior surface irregularities also cause a lot of artifacts. So now we have to think about something which is new entity, corneal tomography, which is elevation based topography. So it uses Schimflug photography, and we see that it takes multiple slices of cornea, similar to how a CT scan machine works. The CT scan machine in neurological the specialty, so it reconstructs all these slices and gives us a three-dimensional reconstruction of the cornea. Look at these three pictures, it explains how a Schimflug camera works. Now in this particular first, we see that the lens plane, this is the regular camera, this is the lens plane, this is the image plane. Now when it is focusing at this particular objects, we find that this area is only focused. But in Schimflug camera, the lens is tilted, and then we can see that this whole particular, all objects are focused in a very nice way, and we can get a complete depth of focus. This is anti-Schimflug, in which you find everything to be blurred. So now all our regular devices work on this principle, and this has really helped in putting up the parameters and data into one proper reconstructed form. So this is a Schimflug image of the anterior segment, and this is one section. So we have the cornea anterior, posterior, the crystalline lens, and the anterior iris surface. Even the iridocorneal angles are visualized. We'll just have a look at this video, which actually shows how things are arranged within a tomography machine. Definitely it is hygienic, non-contact, and we can see the placement of the Schimflug camera within the device in such a way. So we see that the Schimflug camera is on the right side in a tilted way, and we have the central slit lamp with a central camera. So it takes a total 360-degree evaluation, and it takes almost 25 slices of the cornea. So tomography is providing us with Schimflug images. They also give us the AC depth as we saw in the images. Even the volume is calculated. It gives us a detailed pachymetric maps because the anterior surface, posterior surface is also demarcated. Apart from that, with the curvature maps and the elevation maps, it makes things quite easy for the screening of ectasia. So why tomography? Definitely, as we have gone through, anterior curvature is only half story. We need to know the posterior curvature because analysis of the early keratoconus is possible only with the help of posterior curvature. As everybody has been in the literature, it has reported posterior keratoconus is the first to start. Also, for posterior curvature helps for the refractive surgery, especially the cataract refractive surgery, and also for IOL calculations. Now, the complete pachymetric information helps definitely for following up the preclinical keratoconus cases, for refractive surgery screening, and for early ectasia after laser vision correction. So we have wide range of clinical applications with this device, but we are concentrating only on anterior segment imaging, screening for refractive surgery, and phakic IOL. Now this is how a normal shim plug image we did discuss, but this is how the machine demarcates. It gives us a green line. It helps in demarcating the and nicely it elaborates the iridocorneal angle, the anterior surface of the iris, and even the crystalline lens. Now this is an inverted image which is also available with the same devices, and it helps us to find out the LASIK thickness. It could be even 5 to 10 years later, and LASIK flap thickness is one more advantage. It's almost like an ASOCT. Now in this case, a posterior chamber ICL has been implanted, and we can see how the we can calculate the volt. Also at the same time we can find out how much is the iridocorneal angle post ICL. So it helps in follow up of the cases, especially for knowing whether complications can occur in the later time. Another aspect is the cataract density. Apart from the regular cataract screening, post ICL cases, when we want to keep a watch on the crystalline lens developing cataract changes, we can do a cataract density. There is a densitometry in that, and it helps to know whether the cataract changes are happening at a regular follow-up. Now this is a very interesting. We can also use in post dissect cases. We get a demarcation nicely of the lenticule, donor lenticule in the post dissect cases, and so it helps in pachymetry. Also we can study the interface. So it's almost like an ASOCT, and at the same time we can evaluate the angles also. So it's for the follow-up, it's quite helpful. Now coming to the basics of elevation mapping. So what is elevation mapping? Which is the foundation for the tomography devices. This is a normal cornea prolate in shape. It is in a grid form, mesh form represented blue, and this green color is the best fit sphere. So when you put this particular cornea on the best fit sphere, we find some areas of the net-like thing, they are going behind the best fit sphere. Something is above. So those above are given as steep elevation points, which is given in hot colors. Something which goes below is given in cool colors. We'll go into the next slide and try to think more in detail. So when we put a reference surface, we find that something which is anterior is given plus point, something which goes below the reference sphere is given the minus point. So it is positive for red, and it is blue, it is given in negative. Let us have a look. This is a curvature topography map. We have a with the rule astigmatism, but when you look at this, we find that at this area it is given in cool colors, while it is something opposite. But when you analyze this particular picture, we find that there is a steep meridian. It's a toric surface. This is a flat meridian. So when you put the best fit sphere on this green color, we find that the steep areas, they go below the sphere, and so they are represented in cool colors, and the one flat meridian is given in hot colors. So this particular tomography device is quite helpful with the regular cord maps for the keratoconus screening, also for the keratoconus analysis, because if you see, this will be much more detailed spoken about by Dr. K.V. Satyamurthy sir, and we find this curvature asymmetry, these new devices indexes like that VCV, and we also have the keratoconus morphology. So much detail will be taken care by Dr. K.V. Satyamurthy. Also the keratoconus follow-up will be taken care by him, and this is how it helps. We can follow up the different indices over time and try to, it becomes a documentation for us and also for the patient. Apart from that, there is a glaucoma summary also available. With the help of the AC depth and volume, the post-ICL volt, the post-ICL depth, everything can be documented, and it can help us in future follow-up of the studies. So we have slit scanning topography based, which is OpScan, and we have shine plug based imaging devices, that is Pentacam with a single camera. We have Galilee, which is dual shim plug, 2 cameras, and we have a Cirrus Placido. It's a Placido plus Shimplug. So we have two things in one, see this.